Okay, guys, we are on the second part of topic 6, chapter 6, unit 6, whatever you want to call it. So we have finished, not finished, but we have done our notes page on translations. And today we're going to do a notes page on reflections, and then we'll have a practice day kind of going over both of those. I'd rather have a practice day kind of focusing on each, but man, we are getting down to CMAS coming up, so we got to kind of squeeze in things where we can. Okay. So today we're going to talk about analyzing reflections. Reflections, in other words, synonyms you can think about this, would be a mirror or a flip, right? This is not refraction like you would see in science. This is a reflection, or you also see reflections in science. But this is all about reflections, like kind of what you would look, think about like the mirror, right? The mirror has a reflection on it. This is where you're mirroring these shapes, okay? So we've got this one. Dale draws a triangle on grid paper and labels it figure 1. Boom, look at that one, okay? Then, using his pencil as a guide, he basically puts that right there, he draws another triangle directly on the opposite side of the pencil, so the vertical side is now 1 square to the right of the pencil instead of 1 square to the left of the pencil. He labels this triangle figure 2. How are the figures the same, and how are they different? So, a couple ways we can think about this one. I'm going to actually label these A, B, and C. And then I'll label this one as A prime, B prime, C prime. That's kind of how this works. The labeling works when you do your reflections, right? We know this is the new one because the problem told us it was the new one. And it also has this prime notation on it, these apostrophes that distinguish this point A from this point A prime, okay? So a couple ways we can do this is we can measure things to see if they're kind of the same distance. So we have the difference from A to C here is 1, 2, 3, 4, 5, 6. Then we can measure the distance from A prime to C prime. 1, 2, 3, 4, 5, 6. So 6 boxes this way, 6 boxes this way. So that's the same, right? And then the distance from B to C. 1, 2, 3, 4, 5, 6. And same thing. 1, 2, 3, 4, 5, 6. So that's the same distance right there, right? B to C, B prime to C prime, those correspond. And then since it's hard to measure distances across a diagonal, we can actually just use a ruler. I mean, it looks like we're about 4 centimeters right there and about 4 centimeters right there. So it looks like that's the exact same. We can say that see that this is a right angle, matches up to that and that. So yeah, we can see that the angles are the same, right? We could use one of those cool protractor things to measure our angles. Let's make sure. These are, flip it over here. There we go. So we can see that these are 45-degree angles right here, right? And you can see that you line up right there, you line up right there on the lines of the edges of the triangle, and you can see that it's 45 degrees. And then we'll kind of do the same thing. Actually, boom, and then we'll reflect it over here. Do the same thing, make sure it's the same. Yep, 45 degrees right there. And then we'll do the same thing to just, boom, 45 degrees again. This is an isosceles triangle because you have the same side lengths for 2 and then a different side length for the third. So boom, it's 45 degrees right there as well, okay? So we can tell that these are all the same side lengths and the same angles, okay? So what's the same? Right, we'll kind of do like a T-chart here, right? We'll see same versus different. Okay, so the same, we have side lengths and angles, okay? What is different is the positioning, right? The position, okay? So boom, and the fact that it looks like it has been mirrored over the pencil, okay? So we call that the line of reflection right here, okay? So it's basically like you took figure 1 and you kind of like flipped it like that. God, my hands are dry. Good Lord. Drink more water, folks. So yeah, that's what's the same. That's what is the same, and that's what is different. Okay. Okay. Oh, back to this one with these landscape architects and these rich people who have way too much money. Okay. The client wants the architect to flip the placement of the grill, putting it on the other side of the patio. Where does the client want the grill to be placed? So if we are kind of flipping it, putting it kind of over here, there's a line that we're going to flip it over, right? That's basically the same distance here and the same distance here. So it's going to end up like roughly here. Again, there's no numbers on this figure, so it is just an estimation as to kind of where we're going to put that. But that's basically what it would look like. It would be reflected over this line right here, right down the middle. Okay, so kind of how you do that, right? While updating the design, the architect accidentally clicked on the chair and reflected it across the center line. Draw the new location of the chair on the plan. This software that this guy is using is terrible, right? So basically it gets reflected over here. It's the same distance here and the same distance here, okay? So yeah, just like that, right? Again, this doesn't change the size. Okay, doesn't change the size, doesn't change the shape. Okay, so things that are the same size and the same shape are, hopefully you remember this word, congruent. Okay, yeah. So we're not doing transformations that change the size. Okay, yet anyway. So yeah, the chair is still the same size. We haven't like made it bigger, made it smaller. All that's changed is the position of it. Okay. All right. So we have this polygon right here with 5 sides, vertices A through E. Graph and label the vertices of A, B, C, D, E, and its image with all the primes after reflection across the x-axis. Now the x-axis is this horizontal line that runs across right there. So how you do these reflections is you count the distance to the line of reflection, right? So we'll start with A. It is 2 away from the line of reflection, and then you count that same distance on the other side. So it's 2 boxes here, so it's 2 boxes right here. So boom, that's A prime. Okay, and again, we're using prime notation to distinguish the new one, the image, from the original or the pre-image. This is the pre-image. This will be the image. Now we'll go to B. It is 4 boxes away. So we do the same thing. 1, 2, 3, 4. So that's our B prime. C is 5 away. So 1, 2, 3, 4, 5. C prime. Okay. D prime is also 5 away, so that actually goes right next to that C. And then E prime is 2 boxes away, so you just count 2 right there. So we have E prime. Okay. So now you just want to connect your dots. And you can see that this is a congruent transformation because these are the same size and the same shape. Once I am done doing that, okay? So we can see the distance from D to E is 3. The distance from E prime to D prime is also 3, right? So it's a couple ways we can do to check that congruency, right? So you have the same shape and the same size. Okay, we reflected it over the x-axis. We call this the line of reflection. You can think of that. You can think of the line of reflection as the mirror that it's being flipped through or around or over, right? Or reflected around. Okay, so that's that line of reflection. And you can have different lines of reflection. You can have the y-axis as the line of reflection. You can also have individual. You can have like y equals 2. You could reflect it over this line right here. You could even do diagonals. Though we will not be doing diagonals in 8th grade. You will be doing diagonal reflections in sophomore year when you do geometry, or if you have an integrated math program, probably during freshman year. But we will not be doing diagonal reflections this year. Okay. So this is when you write that rule. You have a you have a transformation. In this case, it's a reflection that has already happened, and you are telling the rule that made it happen. Okay, so we have A matching to A prime, D matching to D prime, C to C prime, and B to B prime. Okay, and you can see that it's the same distance, right? A is 3 away. A prime is also 3 away. D is 1. D is 1. D prime is 1. C is 4, C prime is 4, and B looks like 6 versus B prime. Okay, and you can see that they are congruent shapes because they're the same shape and the same size. Hopefully you can see that they have been reflected over this line right here because they're 1 away on each side. This is 3 away on each side and 3 away here. Okay, so they have been reflected over the y-axis. Right, so that's the rule. It's been reflected over the y-axis, right? Easy as that. Okay. All right. That's it for this. I'm going to put it in my notebook here. This is on page 50 for me. So I'm going to take this and fold it in half. Okay, I'm going to put this on page 50. Okay. Real quick, move down there. Okay. And then I'll put it in the table of contents. Okay, so let's zoom that out. We'll put this on page 50. Okay, I'm running out of room here. Huh. Okay, so page 50, this is 6-2, analyze reflection. Okay, that's that, guys.